Hello everyone, and I'm very pleased to be here and kind of a nice spot after these two great presentations before me. But I kind of understand that we are kind of building home for big data, kind of, or the child of the big data. And then what we are building is not very big one because it's not big data yet. So that's kind of where we are at the moment. So more or less, my presentation will be a couple of items. First, I will talk a little bit about the home of the data in Mäntsälä, then the large scale data center construction, which more likely I would say it is the warehouse scale computing, which is relatively new approach. So as we heard, the big data is what to become. So it's not anymore data center where you manage that data. It's more or less a little bit bigger concept. So what we are doing at the moment in Mäntsälä is first stage of Yandex data center here in Finland, which is one of the newest one in our corporate. At the moment we are doing the first module. You can see there is 4 modules in our phases in our data center and office building. We are building a first 10 megawatt module at the moment. So kind of going to previous presentation is that data center is a little bit different concept at the moment. So we rather talk about stuff where the redundancy level, for example, is not inside of the data center, it's beyond the data center, it's data center or between the data centers, which basically means that we are preparing on this level the big data and that kind of stuff, that you are not relying on one data center or one rack, so it's the whole what is the stuff. As we know, everything is growing and going, so we are also open for new technologies, new possibilities to develop and improve stuff, as we heard, which is the future. So, as going a little bit of the traditional data center type and style, in our data center we are using direct air cooling. So by efficiency means, for traditional means, it's one very good approach because we have only one heat transfer process in our data center, is the heat coming from the data center and the servers. That's the only time when we transfer heat across air to water or any other substances. So in that sense it's very efficient because we don't have a need for a lot of additional mechanical equipments. And this is just the technical background, how we have defined and think about how it should work. So most of the time, which is the zone 2 and 1, is that we can cool our data center directly with direct air cooling. This summer, which is representing the number 4 scale, was kind of challenging in that sense because we had a very hot summer. So let's hope that's not repeating often from data center perspective. So, but basically we are not using any mechanical cooling equipment on our data center. The only is the direct air and adiabatic addition on that, so in case the temperatures are very high. Now you wonder why on earth that guy, gray-haired guy, brought up here the wind directions. It has a certain value for us because the building itself is built on shape of airplane wing. So we are using the natural draft and pressure difference between front of the building and end of the building to create a little bit under pressure behind of the building, causing our cooling more efficient. And that's why the location and how the building was placed on our property was based on the normal wind directions. So this is something what most likely coming in other presentation as well, how to choose the location for your data center. And of course, as this is a commercial section of the presentation, why we came in Finland. Yes, we came Finland because we have a lot of competent persons in Finland, so the hiring process on our point has been completed and we found all necessary personnel here in Finland within 3 months when we started our recruiting. So this is one good opportunity to companies to come here. As we all know, we have a stable electricity grid system. Investment globally or locally here in Finland is very good, and also this is something what also other cities and areas and local areas should understand, that the support from the local cities and city authorities is very important to get this kind of investments in locations. And of course, we heard about and we know about the cost of electricity has been decreased due to the tax reduction of the data centers. But now I'm going more deeply, and it was funny that how this whole presentation, what I built up, is kind of reflecting the previous two ones, in that sense that what is the data center project? Because now we are in the edge in that sense, as we heard about the big data and manipulating of the data and analysis of the data, is that the traditional data center is more very simple way and very simple to predict. It's a corporate data center which has number of users, it has office updates, it has very predictable infrastructure and user profile, which means also the funding of the new builds is very simple to do. Technology what is used on traditional or conventional data centers is well known, either in infrastructure side or in IT side. And we have this tier classification invalid, so you can choose what is your level of redundancy inside of your data center. And because all of that, the timeline of the traditional data center build is quite linear. You make a decision, you make a design, you pick a main contractor, you start to build by your design, then you commission it, and then it's handed over you and you start to run your new data center. That's kind of how it worked a couple of years ago. But when we are going amount of data, what we are collecting at the moment, and how it's going to be expanding and going, there's a term in place now, is the warehouse scale computing or warehouse scale computer. So it's not anymore data center in traditional means. It's more or less one big computer, which has a huge amount of mass memory, huge amount of computer capacity, because it's part of the famous cloud. And the redundancy is not inside of the data center, it's between data centers. So, and it's typically, now it's a large scale, in future it will be enormous scale build out. And typically it is owned and manipulated and organized by one organization like Yandex, Amazon, eBay, Google, Apple. So it's in that sense very restricted use on that sense. And typically on these warehouse scale computers, it's very standard, very simple, repeatable hardware inside of it. So it's just the multiple big numbers, or how would I say, I just learned that don't use the big word because it's bigger number than the small number. So, and typically all the services on that warehouse scale computer is managed by one layer or one organization. So you don't have different providers from your office vendor, office tool vendor, or production software AMR vendor. So in that sense, it's coming totally different world. So, as I said, it is very hard to predict, because we don't know how the web users, how the data is collected. Time from the decision to handover is typically relatively short. It's typically less than a year. When we go to traditional data centers, it's easily 18 months and even longer. And VCS projects are, VSC projects are not typically designed ready. So it's 80% design or 70% design and then you start. So this is coming to challenge, and this is where I need to put my blue and white glass on my head and say, if Finland or we as a nation want to compete on this area, this is what we need to learn fast. Because this kind of build-outs and building projects are very challenging and really needs understanding on our design engineer companies, our building companies, little bit different approach. You don't build by the drawing, you build by the need. And that's something definitely what is the challenge on this scale build-outs. As I said, the challenge is from design to construction. You designing same time as you build. So you start on one edge, you have a design ready for shell of the building, little bit of electrical infrastructure design is done, but then there might be changes because you really don't know what's happening in the world. Amount of data is growing rapidly, so basically the technology what is available today might be something it's good for you next year, but it's definitely not good for you year after that. So now you started last year knowledge of your design, and you find during the project, this is not good enough anymore. You need to do a rapid change on the design, scaling, power, cooling, and that's a challenge because traditionally the construction projects in Finland, you build what is on the drawings. And that's very difficult to change. It's also the engineering part of the stuff is, okay, we have designed it already once, why do we need to redesign it? It's good. No. Basic information change, data change. We came up with a different idea about that. And one important, repeatable, and what's need to be repeated. I hope there is some of construction and engineering companies also involved here. And if not, if we can pass this information and tell that this is issue what I have seen in my previous two jobs what I had. I coming to traditional side, I worked 30 years in the traditional IT infrastructure, then jump on this scale, and this is a challenge. This is very big challenge in that sense. And there's also new ideas what we need to learn as a nation. And what is on this kind of project is one of the key learnings. We need to learn to build by 80% design. We need to understand that there will be after fact revised drawings. Like traditionally we say in Finland, you just draw the design after you build, you know what you had. So we need to go, unfortunately, that direction that you build and then you document what you have built, the last 20%, 30% of your data center. And that is causing the as-built documentation, and the processes behind of the as-built documentation should be agreed on each project very early time. Construction. Just going back the same topics because this is basically the main message what I'm trying to deliver here is that also the construction guys, construction companies need to go and understand there is some legislation demand in place, but this is also then the message to our government that there should be means and methods how certain approval processes, acceptances processes, design information is not to be ready on the time when you apply your building permit. So they will approve later on as-built updates or design changes. So also it's coming on that direction that there need to be very good communication to governmental side and city side to understand and get that to be sorted out. And then construction is also, we are very keen, typically in our Finnish construction business, to use the well-known methods how to build. But because of the timeline is so tight and there's changes, there is also need to be very good adaptation and understanding that the methods may change. There may be a change and need to adapt new type of technologies, new type of products to be used, because just due to the size and scalability of these constructions. So it's overall mindset, it's more or less mindset stuff. Changing from our mindset to be fixed, known fact-based builders to flexible, going forward, looking it as a new approach of how to build and get the end to be done. This is, as well as I said previously, this is a challenge for engineering. Engineering and design companies tend to have a little bit of, this is my baby, I know what I designed. But because the client whose end deliverer of the money may change the opinion, or the fact may change during the project, and then also the engineering and the design and the architects need to understand, baseline has changed. We need to adapt that new change to our design. And it's very difficult sometimes to get them to understand, sorry, this is not, we need that year ago, but we don't need that in the future anymore. So this is coming challenging. So the whole warehouse scale computer design build is totally different project, and this is something definitely there is a room and space in our society in Finnish construction and engineering companies to go fast to develop good products for external non-Finnish and Finnish companies. Say, okay, we have a product for you, as we heard. Just give you your specifications and we can build it for you. This is the price tag for it. So, I'm a little bit ahead of time at the moment, so there's time for questions after this one. And yeah, this is the message. Data center is data center, but the big data is living on warehouse scale computers. It's kind of data center, it has the same characteristics but what data center has, but it's totally different approach, how to build, how to maintain, how to operate. Typically on those data centers, they are operated by the organization by themselves, because it's the core of their work. So typically it's not outsourced services what they are using, so it's internal hired people who are running the facilities and all that stuff. So it's totally different world. Flexibility. Flexibility also from client side to understand that there's a time where you can't change, there is time when you need to change. That's applicable for everyone. Construction, design, and also the authorities and the governmental levels, that there need to be built-in flexibility in our system to be able to carry out this level of construction. Of course, it is the scale and timing. As we know and heard how fast the collection of data is increasing. So you don't have time to wait 1.5 years. You are head of your own business if you can get it in 8 months. So for the client, warehouse scale computer data centers are essential to run their business. And that's often forgotten that even month is long time. If there are launch of new applications, new means and methods to collect the data, analyze it. So in that sense, it's very, very critical. Yeah, and the last, I know the pain. This is my design, it's perfect. Kind of. Feeling that this is the common project, everyone has something to give to that scale project. It's not builder, it's not design, it's not the client, it's a team who try to achieve very scalable, big project. And in that sense, and that said, I'm very happy to answer the questions if there is any questions on this moment.
Ladies and gentlemen, that's a very good insight to somebody who's actually doing it right now. I'm absolutely sure we're going to have some questions in here.
Hi. I'm interested to hear that is this data center you have now constructed in Mäntsälä very similar that you're using, for example, in Russia? Is it from technical design?
This is one of the kinds. So this is first this type of data center what we are using at the Yandex. So as we said, in a company, we are all the time seeking the best out of the best. So it is constant development and increasing efficiency, getting it done faster because the young child which come to be big data is behind of the door.
Okay, thanks.
And of course, those were magic words for me. Better, more efficient in Finland. Any other questions? Good, thank you. I think this is a good opportunity, so please think about what you want to ask.
What is the current status of the Yandex project?
The project is that we are doing at the moment infrastructure installations on the site. And our first tests on diesel generators cooling is to be start on within a month. So the aim is to get it done before end of the year.
So I have a question. Does that mean in Finland, on time, in budget?
I would say on time, on budget.
That's what we're promising. Anybody else? Come on, please take the opportunity. Very, very kind of Yandex to come here and tell us what they're doing and why. Anybody else with a question? And some engineers with an engineering question?
And if not here, I'm available whole day here, so just track my sleeve. I put today the long sleeve shirt that it's easier to grab on it.
So I think that's exhaustive questions, and I'd like you to put your hand together and say thank you to Ari. That was superb. Thank you.